This lecture, you're going to learn all about limiting reactants. And as it turns out, you've already seen this before, you just didn't realize it. Remember that day when we made s'mores in chemistry class? Wasn't that a good day, right? And we had a balanced chemical reaction for that. 2 golden grams plus 1 marshmallow plus 1 chocolate chip made 1 s'more, right? And remember, you had questions like, let's say you have 20 golden grams and 12 marshmallows and 18 chocolate chips. How many s'mores can you make, right? This is one of the questions you did. And you guys figured it out without a problem, right? You said, oh, okay, well, if I got 20 golden grams, that makes 10 s'mores. If I have 12 marshmallows, well, you need 1, so that makes 12 s'mores. And 18 chocolate chips mean 18 s'mores. So, well, as it turns out, I can only make 10 s'mores, right? And why do we say 10 and not 18? Because after you make 10 s'mores, 10 times 2 is 20, you're going to run out of golden grams, right? So we are limited in our number of s'mores that we can make by golden grams, because golden grams is going to run out, right? And we're going to have extra marshmallows and chocolate chips, right? If we make 10 s'mores, we'd have 2 extra marshmallows, right? 12 minus 10 is 2, and we'd have 8 extra chocolate chips, okay? That's all limiting reactant is. Okay, the limiting reactant is the ingredient, or of course, we're in chemistry, we're usually not talking about ingredients here or food. We're talking about elements or compounds that runs out in a chemical reaction. And so it limits how much of your product you're going to make. Okay, and then to go along with that, there's called excess reactant or reactants, because there might be more than one, right, with our marshmallows and our chocolate chips. This is the ingredients or the elements or compounds that you have left over because your limiting is going to run out and there might be some of the other stuff that didn't quite get used up. Okay, so let's go back here. Obviously, then our limiting reactant would be our golden grams. Our excess, we would have 2 excess reactants. That would be marshmallows and chocolate chips because we've got extra of those. Okay, so as you can see, the concept, not that complicated. One thing to note, though, is the limiting reactant isn't necessarily the smallest number, right? 20 golden grams was actually our biggest number, but since it takes 2 of them to make a s'more, right, that's why that was limiting. So you can't just look at your numbers. You have to look at your numbers in relation to your coefficients in your balanced chemical equation, and that's what will kind of help you figure out what your limiting is. Okay, so it's not just the smallest number necessarily. So we did a problem similar to this too. Like if I've got 15 marshmallows, how many chocolate chips would I need? And you're like, oh my gosh, Miss Culverson, this is really easy. Yes, it is. Okay, don't make it hard. So if I have 15 marshmallows, for every 1 marshmallow, I need 1 chocolate chip. So I would need 15 chocolate chips. Okay, but what if I only had 13 chocolate chips? Guess what? Then chocolate chips would be my limiting reactant, right? And my marshmallows would be my excess, assuming I had enough golden grams, right? So one way that we typically determine what the limiting reactant is we look at how much of our reactants we have, and we figure out how much the other ones we would need, okay? Just like I did here. If I've got 15 marshmallows, how many chocolate chips would I need? And we're going to do that exact same thing, but now instead of with s'mores and golden grams, we're going to be looking at actual balanced chemical equation with real life chemistry. Okay, so here we go. So here is a chemical reaction. Okay, this is iron 3 oxide plus carbon makes iron plus carbon dioxide. Okay, and so the question here is, okay, well, if you have 1.5 moles of iron 3 oxide, and if you have 2 moles of carbon, what's the limiting reactant? All right, so we are going to figure this out, and we're going to figure it out by comparing how much of our reactants we have and how much of the other one we would need. And I'm going to show you how to do that. So we're going to start with our friendly old cross chart. You know you love it. And so we're going to start with one of the things we know. It doesn't matter which one you pick. I could have started with this 1.5 moles of Fe2O3, or I could put the 2 moles of carbon in here. It doesn't really matter which one you start with, okay? It really doesn't. So I happen to pick this one because it was the first one listed, okay? So I'm going to figure out now, if I have this much of iron 3 oxide, how much carbon would I need? Okay, so I'm going to do this by using my balanced chemical equation, and I'm going to be looking at my coefficients here. So since it started with moles of iron 3 oxide, moles of iron 3 oxide goes on the bottom. I want to figure out how many moles of carbon I would need, so that's going to go on top. My 2 here comes from this 2 coefficient. My 3 here comes from this coefficient of a 3. Okay, so my math is going to be 1.5 times 3, and then you divide that number by 2. Okay, and when we do that, we get 2.25 moles of carbon needed. Okay, so if I start with 1.5 moles of iron 3 oxide, I'm going to need 2.25 moles of carbon. Do I have 2.25 moles of carbon? What does my problem say? No, I only have 2. Oh, so I'm not going to have enough, am I? Ooh, I'm going to run out of that, aren't I? I'm going to run out once I get to 2. So that must be my limiting reactant. Da, 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 da. Okay, so there it is. I figured it out. Pretty easy. I'm going to show you the math now with if you had started with carbon instead. Okay, if I had decided to start with carbon up here instead, I would put my 2 moles of carbon right here. Because I want to get rid of carbon. My moles of carbon is going to go down here. My moles of iron 3 oxide is going to go up here. Again, my numbers, this 3 comes from this coefficient. This 2 comes from this coefficient. So I would do 2 times 2 divided by 3. And that gives me 1.33 moles of iron 3 oxide needed. Okay, if I start with this much carbon, I would need 1.33 moles of iron 3 oxide. Do I have 1.33 moles? Yeah, I got more than that. I got 1.5. Okay, so that shows me I'm going to have extra of this. Okay, I've got plenty of this, but I'm not going to have enough of this. This is going to run out. Okay, so that's why it kind of doesn't matter which one you start from, because either you're going to start and see, nope, it runs out. Okay, this is the thing that's my limiting, or you're going to do the math and say, oh yeah, I've got enough of that. So if you know you have enough of one, you know then the other must be your limiting reactant by process of elimination. You're also welcome to do the math for both and see them both side by side if you want to, but you certainly don't have to. Okay, so that's how I figure out which one my limiting reactant is. So now that we've done that, now we can actually do a problem with it. Okay, so I've got 1.5 moles of iron 3 oxide and 2 moles of carbon. So I'm going to put them together. I'm going to react them. So how much am I going to make? How many grams of iron and how many grams of carbon dioxide am I going to make in this reaction? What am I going to get? Okay, so we've already figured out that carbon is our limiting reactant, and so we're going to do all of our stoichiometry problems now based off of the fact that we're going to use up all those 2 moles of carbon. Okay, so we're going to start with 2 moles carbon in our upper left, and we are trying to get from moles carbon to grams iron. Okay, so first I'm going to do my mole to mole. So, right, moles carbon goes on the bottom, iron goes on top, 3 and 4 come from our coefficients, right? We've done this before, and that gives me 2.67 moles iron. Okay, my next step now is I'm going to get from moles iron to grams iron. Okay, so I'm going to put 1 mole down here. I'm going to put my molar mass off the periodic table right there. Again, we've done this before already. This is not new math. And so once we do this multiplication, we find out that we would make 149.12 grams of iron. Cool. Now we're going to do the exact same thing, but for carbon dioxide, because 2 things are produced, iron and carbon dioxide. That's what my question asked me. So now I'm going to do similar calculations with carbon dioxide. So again, I'm going to start with my 2 moles of carbon because that's my limiting. That's what's going to run out. This time, I'm trying to get to carbon dioxide. So my first step is moles to moles, carbon to carbon dioxide. My coefficients come from here, right? As it turns out, they're both 3. So I start with 2 moles of carbon, and that means I'm going to produce 2 moles of carbon dioxide. Cool. And now my next step is I'm going to figure out how many grams that would be, moles to grams. All right, so I'm going to put my molar mass on top, 1 mole goes on bottom. I'm going to do this multiplication, and I would get 88.02 grams. Okay, so that's how I figure that out. So in this lecture, we learned what the limiting reactant was and how to determine it, and which one is also going to be the excess or the extra. And then we learned once you know the limiting, how can you calculate the amount of product that will be made? Okay. If you want to check out in the textbook, if you want to see what it has to say, this is pages 400 to 403.